Hi there guys, I'm Chris Bowden and welcome to the Geek Group. In this week's Autopsy, we're taking apart an under cabinet mount LCD television. So this normally you'd have like your kitchen cabinets here, and people with more money than brains would have this mounted like under the cabinet, and oh, it folds down this way. Okay, and you would watch TV on the thing. I don't even own a television. I can't imagine why you would actually need one in the kitchen, but maybe you could watch cooking shows. That could be it. It's got inputs on the back, so you could hook it to your VCR or your DVD player or whatever and watch PBS cooking shows. Totally. So let's take it apart, because it's not doing any good here. And yeah, I know it's kind of weird that I spend a lot of time making television and I don't own one. There's nothing on worth watching. So we'll start with popping off all the base screws here. All right, so we've got that off. This might actually be a relatively painless autopsy. You don't need that. Now inside we've got I/O, power supply, speakers, some more I/O over here. Let's break it down a bit. We'll take out some more pieces. The speakers are mounted in a pretty common way. You can see little elephant ear things. By the way, this pink stuff down here, which you can see really well over here, see the red stuff? It's Loctite. It's a glue that is used to hold mechanical fasteners in there. Now look at the back of the speaker, and you get to learn some stuff. Here, we'll take off these little elephant ears that hold the things in. Now look on the speaker there. 4, and the omega symbol means ohm. 5, W, which means 5 watts, and that looks like part of a 3, and then quotation marks. Now this is an important thing to learn because there's 3 things on the back here that tells you a lot. The quotation marks means inches, so 3 inches. This is a 3-inch speaker from that edge to that edge, 3 inches. 4 ohms. This means that the resistance of the coil here from across these 2 electrical connections should be 4 ohms. Ohm is a unit of electrical resistance. Then 5W. Well, W means watts. So this speaker, with its 4 ohm load, is rated for 5 watts of power, and that's how loud it gets. That's how much energy you can put into it. So that's everything you really need to know right away about this speaker. And you'll find that you won't usually see inches. That's kind of rare. But you'll almost always see an ohm rating on the back of speakers, and almost all speakers either 4 or 8. 8 is more common, and if you have a speaker and you don't know, it's always best to start with just assuming it's 8 ohms and go from there, though 4 is really common. There's a lot of other resistances for speakers, especially if you get into weird stuff like headphones and that, like headphones. I've got a pair of headphones that are 32 ohms, so it varies a lot. But with speakers, anything bigger than, an inch or 2, it's probably going to be 4 or 8 ohms, almost always. We'll take out the other 2 speaker screws here. And this is a really common way of mounting speakers, and it works well if you're doing speakers in small projects. You can see the speaker has a rim that goes around the edge here. And then this, I call them elephant ears. There's probably a better term for them than that. But it's just a little tab. This has some goop on it. We don't need the goop. Take the goop off. Okay, you can see this little tab. And it just screws into this post. Get the wires out of the way. It just pushes right on there. And that just holds it in from the rim. And then there's a little glue all the way around. But we can push on this. And the glue is probably soft enough, or we can pop that speaker. If you just push on it, you gotta push gently, it'll go whing and fly out. But let's just apply a little force on there. There we go. It pops right out. Now we've got a speaker. It's See, it's actually a pretty decent little speaker. Hey, it's only a 5-watt speaker. You're not going to get a lot out of it, but it's something, man. Parts is parts. All right. And the speaker goes to a plug right here, which is held in with more goop. And that plug goes out to the speaker. So we'll just cut the wires apart. Because whatever we put the speakers into probably isn't going to have a socket to match that plug. An easier way to get these out is some kind of prying implement. You want to be careful though, because the front of the speakers are very delicate. So you don't want to screw that up. The front of the speakers are just paper. This is the voice cone. The part around the edge is called the surround. And this is the dust cap. Under the dust cap is a tube of wire, a helical coil. And that sits inside the pole piece, which is right here, and then this is the magnet. So dust cap, cone, surround, and that's not the outer rim. Here. Out here, that's the rim. That's the mounting flange. This part right here, the little bendy part, it's usually made of rubber. And if you look at it from edge, you can really see it. It's very prominent. That's the surround. On really old speakers, this is the part that most often wears out. It'll actually rot away with age. Like when they're like 20, 30 years old, they rot away. And then down in here, you can see there's the cone and the dust cap. There's the back of the cone. And then this is the frame. Now down in here, there's a flat piece. It's like another cone down in here, and that's called the spider. And then this is the magnet, and this is the pole piece, and the voice coil's down inside it. We'll do an autopsy on a speaker, and I'll teach you guys all about that. It'll be fun. So we've got 2 good speakers. That's useful parts right off the bat. Let's see what else we can get out of here. We've got the power supply. Now this here, you'll see these a lot. This is the power cord right here. And it comes in this little tube, and it goes around this pin, then it goes out here. This little pin is a strain relief. And what it does is, it means if anybody yanks on the cord, they won't yank parts out of the box. Like if I pull on this, I'm applying energy here, and that would be bad for the transformer. So you put a strain relief in there, and it keeps you from breaking things. But it's important to remove the strain relief if you want to get the transformer out. Okay, so that's that. Our wire is held in place with a little tape. And this is not plugged in, but actually soldered directly to the circuit board in here. And you'll notice we go immediately into the circuit board. We've got 4 diodes right here. Now a diode is an electronic device that lets electricity go through in only one direction. So what this is we've got a transformer. Now a transformer is 2 coils and on a shared core. This takes high voltage, probably 120 volts in, at very low current, and it outputs, in this case, they output a different voltage at a different current. If the volts go down, the current goes up. So this is probably like 12 volts out. So we'll have 120 volts in and only 12 volts out. But if we have 1 amp in, we can have 10 amps out. Volts up, amps down, but the watts always stay the same. So volts times amps equals watts, and you'll get the same watt number on either side. You actually lose a tiny little bit, but not enough to get in a twist over, and for what we're talking about, it doesn't really matter. But there is no free lunch, and the laws of thermodynamics say that as you go through the transducer, you're going to lose a little bit. It actually goes away in the form of several different types of energy. In a big transformer, you will have losses in the magnetic core. You'll have heat losses, which is a lot, and you will actually have losses in the form of sound, which is kind of cool. You can measure that. There's enough there that you can measure the losses in like mechanical vibration, which usually comes off as sound. That's why big transformers hum. Though, Jabbar, you know the real reason why transformers hum? They don't know the words. Ah. Okay. That's actually an old bit. We had a guy years ago in the high voltage lab. We fired up the transformers. You're getting ready to turn on a Tesla coil, and we arm all the big systems, and you hear the transformers, like when you first turn on, go, whoom, and the big transformers come up, and they all start humming. And the guy's like, what's that sound? That's the transformers. What are they doing? They're humming. What do they hum? They don't know the words. And oh God, it was a thing. It was a whole thing. There's a lot of plugs in here. I am so tempted to just start cutting away. But I want to remove stuff reasonably intact so that we can teach you guys about it. There's plugs going everywhere in this thing, and there's plugs on each end. I don't know if it was just for ease of manufacturing or if the people in this factory just didn't know how to solder. Could go either way. All right. Now, what is, oh, that's the antenna. Okay. Don't need that. All right, now, oh, hey, here's something you don't get to see too often because I haven't dealt with radios a whole lot, but here's the component side of the board. Now, there's a lot of tunable inductors and things like that in here. As we look around, we'll see some easy common things like these are capacitors, these are electrolytic capacitors, and you know, there's some little pots down here. Now see these? This is neat, and I'm actually gonna rip one off the board. Let's take it right apart so we can get a good look at it, because I want you guys to see this. So I'm gonna reach down here like this. I'm gonna wiggle this right off the board. Okay, now let's look inside. I need Leatherman Ninja! Bah! There. Let's peel this case back like a tuna can, or like a sardine can. We'll just roll that right out. Because I want to show you guys what this is and how it works. And the best way to do that on this show is rip it apart. It's what we do. Usually we autopsy whole things, but for this one, I'm going to autopsy a specific tiny part as well, so I can share this with you guys. I'm going to poke this right out. Here you can see it right there. Poke out the core. Okay. Now, let's take a close look here. We've got our outer shell, which we don't need, so we'll just get rid of that. Now inside the shell, we've got a core, and this piece is made out of ferrite. Now ferrite is, what's a really good way to explain how ferrite works? Okay, take like a big iron bar and grind it, just cut it, put it through a really serious coffee grinder, and you get iron powder. And you take that iron powder and you pack it around and into a mold so that you can get the iron powder in the shape that you want. And you apply a lot of heat and a lot of pressure, not enough to melt it. You still have little individual particles of iron. It doesn't like melt together like back into a solid like casting iron, but it's kind of a casting process because you're packing it and gluing it all into the shape you want. So you end up with shapeable powdered iron, and that's ferrite. They use this a lot for filters and inductors of various sorts. The little beads that you see on cables, a lot of times, I don't see any right around here, but a lot of times you'll see like a USB cable will have that lump in it, that little egg. Well, that's a ferrite bead, and they tend to just snap in place. That's what ferrite is. Well, what this does is you've got your ferrite here, so that's iron. Well, that works well in reacting in known and repeatable ways with magnets. So now you can see the ferrite bead is hollow. It's like a little can. Okay, so this is like a little trash can type shape. Okay, so there's the bottom of our trash can, and we've got this cylinder around it. So it's a cylinder with one wall. Now this threads into this thing. You can see the little lines there. This is threaded into here. So if I turn this with a screwdriver, it'll move up and down. Okay, so I can turn, the camera focuses on the screwdriver, but I can turn that, and I can actually unscrew it right out of there. Watch. If I keep turning this, it'll unscrew right out of the thing. Oh, it will until I run out of threads. So I'll just pop it out the rest of the way. All right, so there's our little threads down in there. And here's our little cap of ferrite. Okay? Now the little cap of ferrite threads up and down around this little bobbin. And look how tiny that bobbin is. I mean, there's my pinky. Look how tiny it is. It's a cute little thing. Well, that little bobbin is wound with a coil of wire. Let me get a good look here. It appears to be wound with 2 coils of wire, because I don't know if you guys can see that very well, but if you look there, you can see the 4 pieces of wire coming off that tiny little bobbin. So what this does is, by moving the core up and down, that ferrite core, which we've got right here, okay, that's threaded, and that goes up and down on there, you can change the magnetoinductance characteristics of that little transformer. Now that could be a transformer, that could be an inductor, that could be all kinds of different things depending on how the wires are hooked up. So if it's an inductor, you might be changing the frequency. So you could do that kind of thing. So these are used to make adjustments in circuits. And you find these a lot in tuned circuits, like you would for a television. Now this is basically a radio. Now we've got a couple of power supply stages, we've got a couple amplifier stages, there's all kinds of stuff here. Now here's another thing I want to talk about. Remember I mentioned, hey, you don't get to see these very often unless you're taking apart radios? Look at that. That big gnarly thing is a whole bar of that ferrite stuff we were talking about. This is a ferrite bar, and there are different coils wound on it, and this is an antenna. So here, let's take this apart. I need a tool for that. Use my Leatherman. I'll snap this right off. And we've got to cut some very delicate little leads. You can see these. These are actually cloth insulated wires. And now we've got our ferrite antenna. And it's all held together with goop and tape. Whole world's held together with goop and tape. So I'm going to break this off. I'll get the goop out of here. And I'll slide this right off. Oh, what's that? What is that? It's a little piece of rubbery plastic. Now here's our antenna coil. So this is the actual antenna. And then this is our ferrite bar. There. So you can clean that up. Now I got a whole bar full of this stuff. And you can do some cool stuff with this. You can have fun with experimenting with magnetoinductance and magnets and all kinds of stuff like that. This is made of powdered ferrite. So there you go. That's our ferrite bar. We're not going to need that. I'm going to save the ferrite bar. That's kind of cool. All right, so this is just a circuit board. You've seen one. You've seen them all. Nothing else on there that's terribly interesting. So let's look into this part. Hey, we should get that screen out of there. Let's take a look at the screen, because the rest of this, I mean, we've got some other parts on here, but nothing that really excites me. We can look through them real quick. We might get lucky, find something cool, but I'm not hoping for much. I like to explore, though. That's why we do this, just to see what we can see. Okay, so here's a little yellow is video, red is right, and blue is left. These two are audio, that's video, composite. So that's just really just a little terminal block. We've got a power connection here with a diode. That's reverse voltage protection. So nothing exciting there. Now this board here, if you look, you can see it's got this little metal box that sits on the board. Whenever you see a board with a little metal box on it, the little metal box is usually there to shield something inside for radio frequency interference. Now, the trick is knowing which way it's shielding. Is it trying to keep something very noisy in, or is it trying to keep something very sensitive inside from getting noise from outside? And that you have to figure out through more detailed experimentation than we're going to do on this. Now, for this one, we've got our RF input, radio frequency input. So this would come from like your TV antenna. Yeah. So this would be your cable or TV antenna input. And then it goes into here. Now this is probably keeping other noise out from in here, because this would be a very sensitive amplifier or even a preamplifier for the TV, for the broadcast TV. So I'm going to pop it open and see what we can see inside. What I expect to find is a small circuit card with a lot of SMT components. And yeah, that's all that's in there. It's a little circuit card. This is probably an amplifier or even a TV tuner. It's very likely that that's a TV tuner. So tiny little SMT stuff. Nothing really cool. Now let's get that screen off. I need to cut a zip tie. Now there's a lot of wires that go to the screen. There's a whole lot of wires that go to the screen. So first we're going to separate the screen completely from the base. Ah! There's plugs. So pull that out. And now we can get rid of that. And this. Oh, hey. Battery compartment. All right. So how do we get the screen apart effectively? Now here's a neat thing to think about. Look at this hinge. Okay, that's all hinged. And you see there's a ton of wires on this end. And this has two different hinges on it. So those wires got to move all around. How do they get the wires from here to there? Well, they come up here, and they go in this side, and they just wander around in here. And then they come back, probably in the top, might go in the bottom, and down into there. So the hinge has a pass-through tube that passes the wires. We're not going to worry about that. We're just going to get in to the screen itself, because that's where all the coolness happens, and that's what we want to see. Okay. Here's the last one. Okay, now this should pop apart. It should. It doesn't mean it will, but it should pop apart. Am I missing any screws? There we go. That just unsnaps. Now we've still got all those wires that we had before. And I'm actually going to take a moment and take this apart, because the little screen may actually be useful for something. but to use it, we'd want all the wires. Now, I don't have a use for the screen, but this is the Geek Group, and you might have a use for this screen. If you do, I don't want to be the guy who broke it. So I'm going to take this off. I'll take these off. Okay, we got that apart. And now, look, just like I told you, you can see it right there. They come right through the thing. That means we can back pull them right out. And then they go down through that other hinge. We can pull those out. Then we get rid of all this stuff. We don't need any of that. We're down to our happy little screen. Look at that. It's covered in schmutz, but it's lovely. And now, wow, look at all the crap that came out of this. I don't want to know whose kitchen this was in. All right, but now we've got, you can see the back of the screen. This is the driver for the screen, and there'll be a CFL power supply. That's this up here. This is the little inverter that powers the backlight. You don't want to mess with these because they'll bite you. So there you go. And out of all that, we got a couple good speakers. We got a transformer. We got a Ferrite bar. So this, you could just set this up as like a wall display for a computer right there. You could have a whole thing. That could be neat. All right. You guys have fun. I'm Chris Bowden. That's today's equipment autopsy. If you aren't a member of the Geek Group yet and you just watched this whole video, you're one of us. You're a geek, accept it. It's okay. We're here to help. Go to thegeekgroup.org where you can sign up and be a member. It's absolutely free. Or if you want to come here, get involved at the lab, become an IRL member, it's cheap. It's less than $1 a day. You could come here and use these parts and use these tools and build your own ideas. I'm sure you've got some kind of cool idea for this right here. You could be using this. Come get involved. Thegeekgroup.org. And until then, I'm Chris Bowden. And as always, we'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.